All right, this is video 2 of lesson 1. Now we're going to talk about the nature of light, so types of light. There are two ways we can describe objects. We can say that objects can make their own light and emit their own light. We call those types of objects luminous objects. Okay? And of those luminous objects, there are those that were always here, that humanity did not create, and then there are those that were human-made. Okay, so the most obvious luminous object that is natural is the sun. And the other artificial luminous sources could be things we made, like a light bulb that can give off light, a candle that can give off light. Okay, those were things that weren't always around. Now, there's also objects that don't make their own light and they don't emit their own light. And since they're directly opposite to luminous objects, we call them non-luminous objects. So I don't give off my own light. I can reflect light, but I don't give off my own light. So we are not luminous. The moon is not luminous. The moon, as you probably know, reflects the sun's light, and that's why we can see it. Okay? So, having said that, let's take a look at a couple of different types of light emissions. So there's a couple of different types of light. So the first type of light is the light made from the sun. So the sun is a very bright entity. It's what makes living on Earth bearable. Okay, it warms our planet up enough that we can actually live on it, and it provides us a day, okay, versus night. So the way the sun gets its energy and its light from is through this nuclear reaction. Oh, chemistry, yeah. Called a fusion reaction. And what's happening here is when hydrogen atoms in the sun collide together, and they collide with enough force that their nuclei fuse together. And when you get one proton in one hydrogen atom and another proton in another hydrogen atom, and they fuse together, you end up getting 2 protons. And as you remember from chemistry, once I change the number of protons, I change the identity of that element. So who has 2 protons? That would be helium. So when that fusion takes place, a lot of energy is released, and that's the energy we see in the form of light on the sun. So that's the light from the sun. Then we've got light from incandescence, and incandescence is light that comes from heat. And you would have learned this last year in your electricity unit. But if you remember, any kind of light that comes off from heat, it's like a byproduct, okay? And that's what makes incandescent light bulbs so inefficient, because only 5% of the energy that is actually released is light energy. 95% is heat energy. So yes, it works, but it's not very efficient, okay? And I will leave it at that because I know you did incandescent light last year. This is one where we can remember some chemistry, which makes me happy. Light from electrical discharge. So what electrical discharge light is like, so a lot of our street lights are lit this way, is you have a glass tube. Okay, so here's our glass tube. And inside our glass tube, there is a tube that has a specific gas in it. Okay, and then we run an electrical current through this tube with the specific gas in it. And what ends up happening, so I'm going to use, because streetlights are sodium, I'm going to draw a little Lewis diagram of my sodium atom. When I zap the sodium gas with electricity, what that does to the one electron in the valence shell of sodium is it excites that. And so it excites that sodium electron, valence electron, and it goes to another shell, an empty shell. So this is the excited electron. And so it got juiced up. Just imagine like you had a coffee or something, or you had 10. So that electron got excited, but it can't stay excited. because just like you with coffee or me with coffee, you can't sustain that state forever. So eventually, that excited electron has to come back home to what we call ground state. And in coming back down to ground state, it gives off light energy. Okay, so it gives off a certain color of light, and that's the cool thing. Every element has its own color it gives off. So, sodium is a yellow. Copper is a really cool color. It's like a turquoise. It's my favorite. And when you come and take grade 12 chemistry, I'll do this demo. Usually I do it for you when I'm teaching you. But I promise when you take grade 12 chem, I will do this for you. We'll have fun. Moving on. Light from luminescence. So, before we do anything, luminescence is light that is given off, but there's no heat involved. So no heat has been involved. We've got a couple of different types of luminescence we're going to talk about. So number one, fluorescence. So fluorescence is light that is emitted when you expose UV light to your substance first. Okay, so let's think about this for a second. A good example is a fluorescent light bulb. So if any of you have ever broken a fluorescent light bulb, you will notice that a white powder or a yellowy white powder comes out. And the way the fluorescent light bulb is constructed is that's exactly it. So it's kind of like that tube that we were talking about before, the electrical discharge tube, but it's not the exact same because that tube is coated with this fluorescent material called phosphor. Okay, so it's coated with this phosphor, and inside the tube, okay, we've got this mercury gas. Okay, and so mercury, when we pass an electrical current, so you'll see these lovely little electrons, we're going to pass electrical current, and just like the electrical discharge that I told you about, it's going to excite the valence electrons on that mercury atom. And they're going to get excited. They're going to hop up to that excited shell. But remember, they can't stay excited forever. So then that valence electron has to come down. Now here's where it's different from the electrical discharge tube. When mercury electrons come back down, they give off UV light. Okay, so we can't see the light that the mercury electrons would give off, but it's UV light. Now that UV light goes and it excites the phosphor powder, and that's what you see. You see the glowing of the phosphor powder. Okay, and we call that fluorescence. All right. So when we take a look at comparing and contrasting, I'll let you take a look at this because I know you did this in the electricity unit. Fluorescent light bulbs are much more energy efficient, but I do need to say that you can't get rid of these in the garbage because the mercury inside the fluorescent light bulbs is very toxic. We don't want it leaching into our landfills. Okay, so take them back to Home Depot. There's lots of dispensaries for where you should be removing your fluorescent bulbs. Okay, moving on. The next one is phosphorescence. So once again, it has to do with light given off after exposure to UV light, but the difference between phosphorescence and fluorescence is that phosphorescence, that light sticks around for a lot longer after the UV light is gone. So my favorite example, I hope some of you have been lucky enough to get these glow-in-the-dark stickers or glow-in-the-dark solar systems on your ceiling, because what happens is phosphorescent materials, once they're exposed to UV light, it's like they get charged up. And then in the absence of that UV light, that substance gives off its own light. So it emits its own light. Okay, and that's what we call phosphorescent material. So it's the glow in the dark once it's in the dark. All right. Chemiluminescence, we see the word chemi, and that means we're talking about chemical reactions. So once again, no rise in temperature, heat is not involved. So a good example is a glow stick. How do you get a glow stick to work? Well, you crack it, right? Well, what you're actually cracking is within your glow stick. If you take a look, you take a look at this guy right here. Within your glow stick, before it's activated, you've got a little vial of one reactant, and then that vial is surrounded by another reactant. When you crack it, you're combining your two reactants, and then a chemical reaction happens. Okay, so that's a glow stick. That's how they work. Okay, that's how they glow. And if you ever needed to know how to make your glow stick last longer, you put it in the freezer where the molecules move slower and the chemical reaction lasts longer. See, chemistry's everywhere. Chemistry's life, people. Next, bioluminescence. So you see the word bio. This is where we have light being produced within a living organism, so through a biochemical reaction. Good examples of these would be jellyfish, fireflies. There's a lot of deep water organisms that glow on their own because they're in the dark. They need to generate their own light, whether it's for photosynthesis or to scare away predators or things like that. So one great example of bioluminescence is this protein called green fluorescent protein. And it is a gene or a protein, and they found the gene that causes this green fluorescent protein to be expressed, and it's what causes a lot of these organisms to glow. And they've been able, scientists have been able to make their own green fluorescent protein and put it into different organisms. So I actually got to use a mouse who had his cancer genes linked with this green fluorescent protein. And so they could actually monitor where the tumors were being formed by where the mouse was glowing. It's very cool. Next, electroluminescence. So this is light produced by electric currents passing through a substance. So LED lights, your Christmas lights. My daughter just put up a whole bunch of LED lights in her room. They glow different colors. And the beauty of LED lights, yes, they're a little more expensive than your usual Christmas tree lights, but they last forever and they're cool. Not cool as in trendy, but actually they're not warm. And they're very, overall, they're way more energy efficient. The last type of light that we're going to be discussing today is triboluminescence. And that's the light that is produced when you break bonds. Okay, so you're either crushing something physically, like for instance, one of those Wintergreen lifesavers in your teeth, and they give off light as you're crushing them, or you're ripping apart duct tape. So you're breaking bonds, and that gives off light. And the reason for that is because we've got electrons moving around. So here's a nice chart. I'm just going to shrink it so we can see everything. Whoops, there we go. And you can see the definition. So a nice little chart of all the different types of light emission, where you would find them, and exactly what they are. So that's a great summary table. Oh, looky, people. All right, so here's your homework. Whoops, that just went down. So here's your homework. This sheet right here. You also have to do an LMS quiz. All right. And lastly, it's a good idea to watch that video that in the preceding video that I sent you about electromagnetic wave spectrum. Okay. Take care as usual. If you have any questions or concerns, you can use the discussion tool or email your teacher directly through LMS. Have a good day.